Good morning students. Let us continue from where we have stopped yesterday. So you are all requested to watch the previous video before you continue watching this video. So the fifth question is, if C is the center, A dash, B dash are the major and minor axes of the ellipse x square by a square plus y square by b square equals to 1. If Pn is the ordinate of a point P on the ellipse, then show that this is equals to this. We need to show. So let us take the ellipse. So this is our ellipse. So this is x dash, y dash. Now this C be the center of the ellipse, whose center is at the origin for the standard form of the ellipse. A comma A dash are the points on the major axis. Here the major axis is along x axis. A is greater than B. This is B dash, minor axis. So here A dash is the major axis and B dash is the minor axis. So Pn is the ordinate. So let us take the parametric point on the ellipse. So let P theta, A cos theta, B sin theta be any point on the ellipse. So let us take this point P. So this is P, A cos theta, comma B sin theta. So I'll draw a perpendicular from P onto the major axis. So Pn is the perpendicular of P on the major axis. So then, since C is the center of the ellipse, therefore this Cn is equals to A cos theta, and this Pn, which is B sin theta here, B sin theta. So what is Pn here? Pn is the ordinate of P, that is y coordinate, B sin theta. So let us write that. So here Cn is equals to A cos theta, Pn is equals to B sin theta. Next, B A dash is equals to A dash is equals to 2A, B dash is equals to 2B. That means this is A comma 0, this is minus A comma 0, this is 0 comma B, this is 0 comma minus B. So here BC is equals to, this is B, and CA is here, CA is equals to CA dash is equals to, CA is equals to CA dash is equals to A, and CB is equals to CB dash is equals to B, and BC is equals to, for BC, CA both are equal, and here AN, here AN can be written as CA minus CN is AN. So to obtain AN, CA minus CN, CA minus CN. What is CA? CA is A. So minus CN. Cn is how much? Cn is equals to a cos theta. So which we have written before, a cos theta. Likewise, what is a dash n? A dash n. So this a dash n is nothing but Ca dash plus Cn. Ca dash plus Cn. So Ca and Ca dash both are a, therefore Ca dash is equals to a here, plus Cn is equals to a cos theta. A cos theta. Therefore we have everything here. Now, so RHS I'll take. RHS is BC square by CA square. What is BC here? BC or CB is what? It is small b. So this is b square by CA is a. So a square. So this RHS I got b square by a square. Now this also b square by a square is what we need to prove. So for this I take LHS. So Pn whole square by a dash n into an. So what is Pn? Pn is b sin theta. So this is b sin theta whole square by a dash n is a plus a cos theta into an is a minus a cos theta. A minus a cos theta. So this is b square sin square theta by a plus b into a minus b, a square minus b square. So this is a square minus a square cos square theta. So b square sin square theta by, so take a square in common. So a square into 1 minus cos square theta. 1 minus cos square theta is sin square theta. Therefore this is a square sin square theta. So this is equals to b square by a square. Therefore LHS and RHS is b square by a square. Therefore this is proved. S and T are the foci of an ellipse and B is one end of the minor axis. If SDB is an equilateral triangle, then find the eccentricity of the ellipse is what we need to find. Eccentricity of this ellipse. So let the equation of the ellipse be x square by a square plus y square by b square equals to 1 with a greater than b. So if a greater than b is the case, then the supposed ellipse is this. This is our supposed ellipse. Now, so this is a dash, b dash. This is major axis and this is minor axis. C be the center. So this is, now here S comma T are the foci. So let us suppose this S and this is T. So let, given that S is AE comma 0, this is minus AE comma 0. Given that S AE comma 0 and T minus AE comma 0 are the foci of the given ellipse. Because for the ellipse x square by a square plus y square by b square equals to 1 with a greater than b, so foci are S and S dash. Here instead of S dash he has given t, which is plus or minus a comma 0, a comma 0 minus a comma 0. Now here one end of the minor axis is b. B is one end of the minor axis, b dash is another end, but that is not given. So given that b is one end of the minor axis, here STB is an equilateral triangle. This given that, so for the ellipse x square by a square plus y square by b square with a greater than b, this b is 0 comma b and this is 0 comma minus b, b dash is. Now given that STB is an equilateral triangle, that means in equilateral triangle, this angle is 60 degrees, and so all sides are, lengths of all sides are equal. So SB is equals to BT is equals to ST. So let us take SB is equals to ST. Squaring on both sides, SB square equals to ST square. So SB square is nothing but AE minus 0 whole square, distance between the 2 points S and B. So AE minus 0 whole square plus 0 minus B whole square is equals to ST square. So distance between S and T, distance between the foci, AE minus of minus. So AE minus of minus is AE plus AE whole square plus y2 minus y1, 0 minus 0 whole square. This is equals to, this is A square E square, this is B square, this is AE plus AE 2AE whole square, which is 4A square E square. From this, B square is equals to 4A square E square minus A square E square is 3A square E square. We know that B square is equals to A square into 1 minus E square. For the parabola A greater than B, B square is equals to A square into 1 minus E square, that we know, which is equals to 3A square E square. So this is equals to A square minus, so otherwise from this A square gets cancelled. This implies 1 minus E square, 1 minus E square is equals to 3E square. From this 1 is equals to, this minus E square when transposed onto another side, this is 4E square. So 1 by 4 equals to E square. Therefore E square equals to 1 by 4, where E is equals to 1 by 2 is the eccentricity of the ellipse. The orbit of the earth is an ellipse with the eccentricity 1 by 60, with the sun at one of its foci, the major axis being approximately 186 into 10 power 6 miles in length. Find the shortest and longest distance of the earth from the sun. We know that the path of the orbit of the earth is ellipse. So let us suppose that this is the orbit of the earth. So now, this being the center of the ellipse, and let S comma S dash be the foci of this elliptical orbit. So S is the position of the sun. Let us suppose that this is the earth. So the position of the Earth is here. Let S be the position of the sun. Let S be the position of the sun. Let E be the position of the earth. Let the orbit of the earth be x square by a square plus y square by b square is equals to 1. What is given is the major axis being approximately 186 into 10 power 6. Major axis means what? A dash. A dash being the major axis and B dash being the minor axis. Given that the length of the major axis is A dash, which is equals to 2A, that is given as 186 into 10 power 6 miles. So 2A is this, therefore A is equals to 186 by 2, which is 93 into 10 power 6 miles. Given eccentricity E is equals to 1 by 60 is given. Now we know that the shortest and longest distance from the sun is A and A dash. From the sun is A and A dash. That is SA. So SA being the shortest distance. What is SA? S is AE comma 0. So this is square root of AE minus A whole square plus 0 minus 0 whole square, that is 0 anyway. So square and root gets cancelled. This is AE minus A. So AE minus A, so it could be A minus AE as well. So modulus of. So this is, we will get either AE minus A or A minus AE. So and the longest distance from the sun is SA dash. SA dash is nothing but AE minus of minus. So this will be AE plus A. These are the shortest as well as longest distances from the sun on this ellipse. Now SA is equals to, if you take A in common, then we'll get 1 minus E. So A is 93 into 10 power 6 into 1 minus 1 by 60. E value is 1 by 60. So that is 93 into 10 power 6. 61 are 60 minus 1, which is 59 by 60. In 1, 4, 5 into 10 power 6 into 10 power 6 miles. Likewise, SA dash is equals to 93 into 10 power 6, 1 plus 1 by 60. 1 plus 1 by 60, which is 61 by 60. This is equals to 9455 miles. Now let us discuss the point of intersection of the ellipse and the straight line in a plane. So that is the relative position of a straight line with respect to ellipse. Let us suppose that this is our ellipse. So the relative position of straight line with respect to the ellipse in this plane could be either the straight line may be like this, or it may be like this, or it even be like this. So depending on the discriminant. So let us see the point of intersection of the ellipse x square by a square plus y square by b square equals to 1, and the straight line y is equals to mx plus c. First let us solve these two. How? Solving them, we get x square by a square plus y is equals to mx plus c. Substitute here. So this is mx plus c whole square by b square equals to 1. This is equals to LCM is b square x square plus a square into mx plus c whole square by a square b square equals to 1. If you cross multiply with 1, we'll get a square b square. So this is equals to b square x square plus a square into a plus b whole square. You expand. So this is m square x square plus c square plus 2 mcx is equals to a square b square. Now this is equals to x square into b square plus a square m square plus this is 2 a square mcx plus a square c square. This plus a square b square, if you transpose onto another side, this is a square into c square minus b square is equals to 0. If you see this is a quadratic equation in x square, x and constant equals to 0. This is a quadratic equation in x. So since this is a quadratic equation in x, this equation have got two roots. Let the roots be x1 comma x2. So if two roots, that means the two roots may be real and distinct or coincident, or even it is imaginary. So depending upon the discriminant. What is the discriminant? b square minus 4ac is greater than equals to 0, or is equals to 0, or less than equals to 0. If the straight line intersects the ellipse at only one point, then that line is said to be what? A tangent to the ellipse. Therefore, this straight line will be touching to the ellipse. So now we will derive the condition for the line to be a tangent to this ellipse. So is what? b square minus 4ac equals to 0. So what is b square here? So this is ax square plus bx plus this is all c. So ax square plus bx plus c equals to 0. So the discriminant is b square minus 4ac equals to 0. So the objective to behind doing this is we are trying to establish a relation when this straight line touches this ellipse. Now, what is b square here? What is b? This. B square is 2a square mc whole square. So this is 4a power 4 m square c square minus 4 ac. A is this b square plus a square m square. C is a square c square minus b square is equals to 0. This implies, so 4a square if you take common, then we will have here a square c square m square. So 4a square we have taken common, therefore here we are getting a square m square, a square m square c square, a square m square plus b square. 4a square we have taken common, so we are left with a square m square plus b square into c square minus b square is equals to 0. So this 4a square if you transpose onto another side, it will be simply 0. This implies a square c square m square, this is minus a square m square c square, a square m square c square. Next, minus this is equals to a square m square c square minus a square m square b square plus b square c square minus b power 4 equals to 0. So this is equals to a square c square m square minus a square m square c square. These two gets cancelled. So minus into minus plus a square m square b square. So minus b square c square minus into minus plus b power 4 equals to 0. B power 4 is equals to, this is, if you transpose onto another side, this is b square c square minus a square m square b square. So this is b square into b square is equals to, take b square in common in both of them, then this is c square minus a square m square. So b square gets cancelled. So b square, this minus a square m square, if you transpose onto this another side, a square m square is equals to c square. Therefore, this is the condition for the straight line. For the straight line, y is equals to mx plus c to be a tangent to the ellipse x square by a square plus y square by b square equals to 1. Thank you.